In topic 6, we're going to be looking at factoring special polynomials. So these polynomials actually have shortcuts for us to take to factor them faster. So let's start off with perfect square trinomials. Now up here, I broke down exactly what a perfect square trinomial is, but let's take a look at this formula here. A squared plus 2ab plus b squared could be factored to a plus b squared. Now what this means is if you can take the square root of the first term, so the square root of a squared, that would just be a, because a times a equals a squared. And then if you can take the square root of the last term, so this b squared here, the square root of it would be b, then the middle term has to equal 2 times a times b. And if that's the case, then you can factor it as a plus b squared. This formula over here is basically the same thing, except this sign right here is different than this one here. So when you're given a trinomial and you recognize that it's a perfect square trinomial, also take a look at this sign here because that sign determines what sign will be in here when you factor it. So let's look at example 1 and break this down. So in example 1, factor the following trinomials, verify by expanding. So you're probably wondering, well, this just looks like the last topic we did where we used the crisscross method. Can't I just use that to factor this? Well, you absolutely can, and you'll get the exact same answer. This is just another way to solve these problems. So let's look here. 16x squared minus 48x plus 36. So when looking to see if a trinomial is a perfect square trinomial, and we could take this little shortcut, we want to see if we could take the square root of this term and the square root of this term. So the square root of the first and the last term. Now remember, it has to be in descending order. So let's take the square root of both of these. So the square root of 16x squared, that would be 4x, because remember, we have to take the square root of the 16 and the square root of the x squared. And the square root of 36 is 6. So these two values here are the a and the b that we looked at above up here. So now let's think. Does our middle term, 48x, equal 2 times a times b? Well, that would be 2 times 4x times 6. And then we're going to multiply all the big numbers together. So 2 times 4, that's 8. And 8 times 6 is 48. And then we still have that x there. So yes, the middle term is equal to 2 times a times b. So this is indeed a perfect square trinomial. So once we verify that this is a perfect square trinomial, we don't have to use the crisscross method. We can skip right to this step here or here. So before we choose which one we're going to use between these two here, we need to look at this sign right here. So if we're looking at our trinomial, we have a negative sign there. So when we factor this and take the shortcut, we're going to be going for this one right here with the negative sign in the middle. So therefore, the answer for this, if we were to factor it, would be, I'm going to open my bracket, a minus b squared, because we have that minus sign there. And our a, we said, is 4x. That's the square root of the first term. And our b is 6. So 4x minus 6 squared is our answer for this, and we're done. Now let's check this. So 4x minus 6 squared, that is the same as writing 4x minus 6 times 4x minus 6. And if we were to FOIL this, the first terms would be 4x times 4x, which is 16x squared. The outside would be 4x times negative 6, which would be negative 24x. The inside again is negative 6 times 4x, which is another negative 24x. And then the last terms are negative 6 times negative 6, which is plus 36. And if we were to combine like terms here, we would get our original expression. 16x squared minus 48x plus 36. And it matches, so we know we factored this correctly. So let's look at the next one here. X squared plus 10x plus 25. So let's check to see if this is a perfect square trinomial. So we're always going to focus on that first term and that last term and see if they're perfect squares. And if they're perfect squares, that means we can take the square root of them without having any decimal numbers. So the square root of x squared, remember there's an invisible 1 out here. So the square root of x squared would give us x, and the square root of 25 would give us 5. So we could take the square root of both of those terms. Cool, that's step number 1 that we have to check. Now let's check if that middle term is equal to 2ab. And remember that x and that 5 are the a and the b. So 2ab, that would be 2 times x times 5. And if we were to continue solving that, we would have 10x, which is equal to that middle term there. So this is indeed a perfect square trinomial. So let's use our shortcut instead of crisscrossing. So the shortcut we're going to use this time is, well, there's a plus sign in this spot, so we're going to use this one right here. So instead of writing it with the negative sign in between like we did in the previous example, we're going to write it with a plus sign there. So our answer is going to equal a plus b squared. Or in other words, the a that we have is x, and the b that we have is 5. So x plus 5 squared is our factored answer. And I'll go ahead and check our answer here to make sure we are correct. So I went through with foiling our final answer here, and I do get the original expression, so we did factor this correctly. All right, here's another one we can look at. Now, I personally always like rearranging it into descending order. It's just easier for my brain to look at. So let's rearrange it. Let's put this 25x squared term first. So we'll have 25x squared. Then if we're going in descending order, the next one would be negative 20x. And then finally that plus 4 at the end. So let's figure out what our a is. So if we were to take the square root of the first term here, we would have that our a value is equal to 5x. And if we were to take the square root of the last term here, we would have that b is equal to 2. So now let's check this 2ab, does that equal 20x? We would have 2 times 5x times 2. And 2 times 5 is 10, times another 2 is 20. And then we have that x. So yes, it does equal the middle term there. So this is indeed a perfect square trinomial. So let's take our shortcut. Remember to always look at the sign that's here to determine whether it's going to be a plus b or a minus b. So in this case, there's a negative sign or a minus sign. So we're going to write it as a minus b squared. Or in other words, a this time is 5x and b is 2. So 5x minus 2 squared. And now I'm going to go ahead and check this answer using the FOIL method. So now I just checked our answer using FOIL, and it does match this expression we have up here, so we know our factoring is correct. Let's look at example 2. Is 4x squared minus 25x plus 36 a perfect square trinomial? So let's go through all our steps. Let's figure out what our a and b are, and let's see if that middle term is equal to 2ab. So if we were to figure out the a, we would take the square root of this first one, so a is equal to 2x. And then to figure out b, we would take the square root of this last one here. So the square root of 36 is 6, so our b is 6. Now let's see what 2ab is equal to. That would be 2 times 2x times 6. So 2 times 2 is 4, times 6 is 24. So in the middle here, we would have 24x. Does that match our expression? No, it doesn't. We have 25x in the middle here. So it does not match. And because those don't match, this is not a perfect square trinomial. So let's write a little side note here. This needs to equal the middle term, which is 25x. Since it does not, this is not a perfect square trinomial. And we're done with this question. The next type of special polynomials we're looking at are trinomials with two variables. So if you look at example 3 here, you'll notice that we have an a squared on this term, but now we also have a b squared on the last term. So although these ones look more confusing, they're actually exactly like the ones we did before, except when we do our crisscross method, we're going to have variables on this side of the crisscross and we're going to have variables on this side of the crisscross. Before, we would only have variables on this side here, and these values over here would just be numbers. So let's just work with the crisscross method. So let's start our crisscross off by looking at the first term here and thinking of two things that would multiply to equal 2a squared. Well, the only possible thing would be a times 2a. Now let's look at the 3b squared. Two things that multiply to equal 3b squared would be 3b times b. So let's do our crisscross. 2a times 3b gives us 6ab. And now a times b is equal to 1ab. Remember, there's an invisible 1 out front, so just ab. Now, is there any way we can add or subtract these two to get -7? There sure is. We could do -6 and then negative invisible 1 there. So -6 minus 1 would give us -7ab, which is equal to our middle term. So let's put these signs in here. So there's a negative sign on the top and a negative sign on the bottom. And of course, there's that final thing to check. Does a negative times a negative give us a positive? Yes, it does. So we're all good with all of our checks. Therefore, our factoring is correct here. So if we were to write our final answer, we would get a minus 3b times 2a minus b, and we're done. So now let me verify this answer using the FOIL method. The word verify and the word check are the same thing, by the way. So if we're going to verify this, a minus 3b times 2a minus b, using FOIL, let's start with the first term. So a times 2a, that would be 2a squared. Then the outside would be a times negative b, so that would be negative ab. The inside would be negative 3b times 2a, which would be negative 6ab. And negative 3b times negative b is positive 3b squared. And if we combine like terms, these two in the middle are like terms, so we would have 2a squared minus 7ab plus 3b squared. So our answer is correct because it matches the original expression. Let's do one more of these. 10c squared minus cd minus 2d squared. So if we were to think of two things that multiply to 10c squared, we could either do 1c times 10c, or we could do 2c times 5c. I'm going to do 2c times 5c. Now for 2d squared, there's only one option we can do. That would be d times 2d. So if we were to crisscross this, we would have 5c times d. That equals 5cd. And 2c times 2d, that is 4cd. And is there any way for us to get negative 1cd in the middle? Yep, there is. We could do negative 5cd plus 4cd. That would leave us with negative 1cd, or just negative cd. So that means we would have a negative sign on the top here and a positive sign on the bottom here. And one more check. Does a negative times a positive give us a negative? Yes, it does. So we know we're all good here. So our final answer factored will be 2c minus d times 5c plus 2d. And now I'm going to check this by foiling it. So 2c times 5c, that would be 10c squared. Then the outside we have 2c times 2d, that would be plus 4cd. The inside would be negative d times 5c, that would be negative 5cd. And finally, negative d times 2d, that would be negative 2d squared. And let's combine these like terms. So we have 4cd minus 5cd, that leaves us with negative 1cd. And then that negative 2d squared on the end. So yes, it matches our original expression, so our factors are correct. Now I just want to do a little side note here. Whenever we're writing terms that have multiple variables, we want to put those variables in alphabetical order. However, if you don't put them in alphabetical order, that doesn't mean it's a different term, and it doesn't mean that it's equal to something else. It still equals the same thing, it's just not grammatically correct in the math world. So for instance, 4CD is the correct way to write it. We have the coefficient out front, and then these variables are in alphabetical order. But that's the same thing as 4DC. That's also the same thing as D4C or C4D. These are all equal to the same thing, but make sure you're writing it with the coefficient out front and then the variables in alphabetical order. Now, the final special polynomial we're looking at is difference of squares, and this is the easiest one of the bunch. So difference of squares only has two terms. So they're binomials. And I remember seeing this on a test in high school, and I was like, how am I going to crisscross factor this? I have no idea how. There's only two terms, and it made me really confused. So I got the question wrong, and then I got the test back, and I was like, oh, it was difference of squares. So whenever you see two terms and you need to factor it, immediately think, is this difference of squares? Is there anything I can do with that? Because it most likely is. So let's look at example 4. Factor each binomial. So when we're looking to see if a binomial can be factored using difference of squares, there's two things we need to look for. The first thing is we're looking for squares or perfect squares. So the first term has to be a perfect square and the second term has to be a perfect square. And in order to check that, take the square root of both of them and see if you get a whole number. Now, the second thing we need to look for is it the difference of the squares? Now, remember in math that the word difference is a special word for subtract. So you're looking for two squares or perfect squares that have a subtraction sign in between them. If they have a plus sign, this will not work. So if you have two squares that have a subtraction sign in between them, you would take the square root of both of those squares and you would get an a and a b value, just like we did for perfect square trinomials. And then if there's a negative sign in between them or a subtraction sign, then we can quickly factor it as a plus b times a minus b, and we're done. So let's look at example 4a. So we have a binomial here. So it has two terms. Let's see if both of those terms are perfect squares. Can we take the square root of both of those? We sure can. We could do the square root of 25 and the square root of 36x squared. So we would get 5 and we would get 6x. So that there is our a and our b. And the second thing we have to check is it the difference of squares? Is there a subtraction sign in between? Yes, there is. So I'll do a little side note here. Must have subtraction sign in between. So because both of the terms are perfect squares and because they have a subtraction sign in between, we can use difference of squares to factor this. So in other words, 25 minus 36x squared is equal to, well, we said our a is 5 and our b is 6x. So we're looking to put it in this form here, a plus b times a minus b, or in other words, 5 plus 6x times 5 minus 6x. And there's our final answer. So I'm going to verify my answer to prove that this works. So we have 5 plus 6x times 5 minus 6x. So if we were to FOIL this, we would have the first terms, 5 times 5 is 25. The outside would be 5 times negative 6x, which is negative 30x. Then the inside terms would be plus 6x times 5, that's plus 30x. And then the last terms are 6x times negative 6x, which is negative 36x squared. And if we were to combine like terms here, negative 30x plus 30x is equal to 0x. So those terms cancel each other out. which is why we're only left with two terms at the end, 25 minus 36x squared. So that is equal to our original expression up here, so our answer is correct. Let's try this last one here. Now you're probably looking at this and thinking, oh, those aren't perfect squares. I don't know how to take the square root of 5 and the square root of 80. Well, don't forget about factoring out that GCF, that greatest common factor. So in this case, if we're looking 5 and 80, well, we could factor a 5 out of both of those. So our GCF here is equal to 5. So if we were to factor out a 5, we would be left with x to the power 4 minus 16y to the power of 4. And now what's left in the brackets here is difference of squares. So we can follow our rule. If we take the square root of x to the power of 4, that leaves us with x to the power of 2, which is our a value. And if we were to take the square root of 16y to the power of 4, we would be left with 4y squared, which is our b. So let's factor this here. So for difference of squares, remember we're doing a plus b times a minus b. So our answer for this one here would be, don't forget that 5 out front, and then we would have our a value, which is x squared. So x squared plus the b value, which is 4y squared, times our a value again, which is x squared, minus our b value, which is 4y squared. Now this one here is actually a tricky one because our final answer here isn't our final answer. If you look closely in there, we have a new difference of squares. It's right here. We got a negative sign in between two perfect squares, or two terms that we can take the square root of. So in this case, the new a value is the square root of x squared, which is x. And our new b value is the square root of 4y squared, which would be 2y. And I want to give you a heads up that this here is not difference of squares, because remember, it has to be the difference. There has to be a subtraction sign there. So if we were to factor this one more time, these two first parts would stay the same. So we would have 5 times x squared plus 4y squared. And then beside here is where we would do our new difference of squares. So our a is x and our b is 2y. So we would have x plus 2y and then x minus 2y. And now this is completely factored. This one is a tricky one, so let me know if you need any help with this.